Hey, what's going on, guys? It's Nate here from thetechunion.com, bringing you the 5th tutorial in the Java and APCS tutorial series. In this video, we're going to be talking about base arithmetic. This will be the last video on the topics of the basics of base conversion. We might do a little bit, I'm probably going to do a couple more videos on base conversion far into the future over the more advanced topics like negative bases, negatives, 2's complement, and of course some of the Java functions that deal with bases. But this will be the last video on the basics, and then in the next video we're going to start programming. I'll talk a little bit more about that at the end of the video. Alright, so let's get into it. In this video we're not really going to be learning anything new. Similar to the last video, we're just going to be combining what we already know into something a bit more useful. So we're going to be talking about base arithmetic, operations in different bases, and so we're going to be talking about addition, subtraction, multiplication, and division. There's going to be a 4-question lesson and a 2-question quiz at the end of the video, so that's what we're going to be doing today. So the steps for evaluating an expression that is in different bases into your desired base or base 10 is to take each number or term or factor in your expression and convert it to base 10. And then once you have all the numbers in base 10, you go ahead and do arithmetic like you normally do in base 10. So, and then you can go ahead and convert it into your desired base, or if you're already working with base 10, then you're good to go. So let's go ahead and take a look at this with number 1 and some basic addition. So what we need to do first is convert 1001 base 2 into decimal. So let's go ahead and do that. Make a chart. 2 to the 0, 2 to the first, 2 squared. I can make a better 2 squared than that. 2 squared, 2 cubes. Alright, and then that value, we evaluate these, we get 1, 2, 4, and 8. So those are the values: 2 to the 0, 2 to the first, 2 squared, and 2 cubed. So 1 times 8 is 8, and then we ignore the zeros, and then we add 1 times 1, so 8 plus 9. 8 plus 1 equals 9, I should say. So 9 base 10. So 1001 base 2 is 9 in base 10. Now let's go ahead and do this with the other number. Let's go ahead and erase all this. We can go ahead and reuse our chart for the next number. So this one is 1110 base 2. Or 1110 if you're just reading the digits. So 8 times 1 is 8 plus 4 plus 2, so 8 plus 4 plus 2. That gives us 14 base 10. We go ahead and put that down here. Alright, so let's go ahead and clean this up a bit, and then we can go ahead and finish this problem. Maybe go ahead and pause. Alright, so if we go ahead and add, now that we have both of the numbers in base 10, we can go ahead and do arithmetic like we usually do. So 9 plus 14, that equals 23. 23 base 10. But we also want this number in binary. So what we can do is come over here, because we're going to need some space for doing a little bit of mountain division. And we're going to, from now on, we're going to do mountain division for small numbers, and then as they get pretty large, we're going to start to use the remainder division, because the remainder division works better with larger numbers. Alright, so you don't have to keep dividing and dividing. So mountain division, let's do 2. Put a 2 down here. Let's 2 goes into 23 11 times with a remainder of 1. And we can go ahead and check that. 22 plus 1, 23. Continue. 2 gives us 5 with a remainder of 1. Go ahead and check that. 10 plus 1, 11. Yep. Alright, go ahead and 2. 2 goes into 5 2 times with a remainder of 1. So 2 times 2 is 4 plus 1, 5. Good. 2, 1, remainder 0. And 2, yep. And divide by 2 one last time. We get 0, remainder 1. Make sure we did this right. So 11, 22, 23, 10, 11, 4, 5, 2, 2, so 0, 1. Yep, okay. Now we went up the mountain, so we gotta go down the mountain now when we want to read our answer. So we're gonna write this as 1, 0, 1, 1, 1 in binary. So that is the first problem, how you do addition in other bases. Now let's take a look at a subtraction problem where some of the numbers have different bases in the expression. So there's another method you can use actually, but I'm not going to be teaching it because it's not as universal and you can't use it in as many applications, where you pretty much take, like, you have a number like 110 base 2 and 1 base 2, and then you like add like you normally would, so you get 1 1 base 2, and you can go ahead and like if it was like this, whenever you have to carry the digit, you have 1 and 1, that's 2. You can't have 2 in base 2, so you put down a 0, you carry the 1, and then you have 1 and 1, you can't have 2 in base 2, put down the 0, carry the 1, and you get 100. So that's 3 plus 1, so 4. Yep. So that's the other method, but the problem with that is if you have multiple bases in the same expression, you can't really use that. And it also, for me, it just seems a little bit easier to use what we've already learned and go ahead and use those methods. So we're going to be using those for these videos. I can't English. Okay, so we have 72 base 8 minus 1021 base 3. So let's go ahead and convert both these numbers into base 10. So let's make the table for base 8, 72. We don't have to write, I was about to say we don't have to write powers anymore, but why not? It helps. So 8 to the 0, that's 1. 8 to the first is 8. So we got 8 to the 1, 8 to the 0. So 8 and 1, we go ahead and write this out as 7 times 8 plus 2 times 1. 7 times 8 and 2 times 1. We add those together. We multiply then add, so 49, 56 plus 2 equals 58 base 10. So this number is 58 in base 10. 72 base 8 is 58 base 10. 58 base 10. And in this problem we have to convert it into base 10, base 3, and base 8, so we'll worry about getting it to base 10 first. So we got the first number in base 10. Now let's get the second number in base 10. Let me pause and erase. Alright, let's go ahead and make the chart for the number that is in base 3. So we have 1021. Let's go ahead and write the powers of this number. So yeah, 3 to the 0, 3 to the first, 3 squared, and up to 3 cubed. Yep, 3 cubed. So we go ahead and evaluate these powers, these exponents, and we get 3 to the 0, that equals 1. 3 to the first, that equals 3. 3 squared, that equals 9. 3 cubed, that equals 27. So we have 27, 1 times 27, let's write like that, like we did with the other one, plus 0, where we have the digits outside the parentheses, and then the place value terms inside. So 0 times 9, and we add 2 times 3, and 1 times 1. Finally, so you can see our number right here, 1021. Yep, and 27, 9, 3, and 1. So we'll go ahead and add these. So we get 27, and then 3 times 2 is 6, so 33 plus 1, it gives us 34, base 10. Alright, so 34 base 10. So 58 minus 34, that would give us 24 in base 10. Now let's go ahead and convert it into base 3 and base 8. So this video might be a little bit long since we're converting into different bases for our answers, but yeah, most of the time you don't have to convert into multiple bases. You might just have to only do base 10, in which case it's really short, or just a different base. Might not have to do up to 3. Voice crack. Should have drank more water. You don't have to do multiples of 3 or more usually. Alright, need some water, I guess, so we'll just go ahead and ignore that for now. So we got 24 base 10. I'll just edit it out, don't worry about it. So 24 base 10, and we got let's go ahead and convert this into base 3. So we can go ahead and do mountain division here. So 24 divided by 3 is 8, remainder 0. Divide by 3 again, that gives us 2, remainder 2. What was that, 2? 2. And then divide by 3 again, we get 0, remainder 2. Let's make sure we did that correctly. 8 times 3, 24 plus 0. 3 times 2, 6 plus 2 is 8. 3 times 0, 0 plus 2, so 2. Yeah, we did it correctly when we went up the mountain, so now we have to read down the mountain. So 220 in base 3. We can go ahead and check that if we want. So this is the 1s, this is the 3s, and this is the 9s. So 9 times 2 is 18, plus 2 times 3 is 6, so 18 plus 6 is 24. Alright, so let's go ahead and do base 8, and then we'll be done with this problem. So this is probably the longest one. 3 and 4 shouldn't take that long, and then the quiz, they're pretty fast. They go pretty fast, except for number 1. Or I guess that's half the quiz then. I'm so evil. So 1f times 1f base 16 times. Okay, whoa. Okay, sorry, I got off track. We're still on number 2. All right, so let's convert 24 into base 8. We're getting ahead of ourselves here. So so 24 divided by 8, we get 3, remainder 0. Divide by 8 again, we get 0, remainder 3. And then so 24 is 30 in base 8. So if we can go ahead and check that, 3 times 8 is 24, plus 0 is 24. Alright, now we can go ahead and move on to number 3. So let me go ahead and erase and we'll be there. Alright guys, we have 1f base 16 multiplied by a base 16. So let's convert all the factors that are in hexadecimal into base 10. So let's go ahead and make a chart again one last time, and remember f is has the same value as 15. So f is, okay, so we have 16 to the 0 and 16 to the first. So we have 16 to the 0, that equals 1. 16 to the first equals 16. First two digits for converting base into base 10, pretty easy because they're powers of 0 and 1, but it gets a little bit more difficult once you get into squares and cubes and all that. A little more difficult to calculate by hand. So let's go ahead and write this out as 1 times 16 plus 15 times 1, because remember f is equal to 15. So 1 times 16 and 15 times 1. We add those together. 16 times 1 is 16 plus 15 times 1, so that's 15. So 16 plus 15, that gives us 31 for our answer in base 10. So this is written as 31 in base 10. Now let's go ahead and convert a base 16 into decimal. This one shouldn't take that long since it's one digit, or whoops, messed that up. One symbol representation or digit or whatever you want to call it. Probably symbol representation since it's letter. So, oh my gosh, takes so long to erase and paint. Okay, finally, 5 years later. Alright, so we got 31 in base 10 multiplied by, okay, so we got a base 16, so 16 to the 0, which is equal to 1. So call that, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a equals 10. So 10 times 1, that is, of course, 10. So a base 16 is 10 base 10. 10 base 10. Now we go ahead and do our arithmetic like we would normally would. Oh my gosh, these numbers look atrocious. 31 is 10. Alright, stupid right click. Alright, so that's slightly not worse. 31 times 10, that gives us 310. I know how to write, so 310 base 10. Okay, that is not acceptable. Let's zoom in a bit, write this. So 310 base 10, because got 31, 1f is 31 base 10, and a is 10 base 10, and then you do multiplication like you normally would, so 310 base 10. And now we can go ahead and convert this into base 16 hexadecimal. I don't know what's with me today. So just go ahead and erase all of this, and we can continue on. Alright, so we have 310 in base 10, and we want this in base 16 hexadecimal. If we go ahead and do remainder division, we can save a lot of time here. We can divide by 256. That gives us 1, with a remainder of, let's see, 54 it looks like. Yeah, 256 plus 54, yep, alright, and then we, oh, not mountain, so now we divide 54 by 16. 54 divided by 16. That gives us 3. 16 times 3, that gives us 48. Remainder 6. So now we divide 6 by 1. And then we get 6, remainder 0. It's worth noting, whenever you're doing remainder division, you should always finish with a remainder of 0. And whenever you're doing mountain division, you should always have a result in the final division of 0. So let's just make sure you're finished. So let's go ahead and write this down now. So we have 1, 256, we have 3 16s, and we have 6 1s. we can go ahead and check that if we'd like. So 1 times 256 plus 48, 3 times 16, so 298 plus 304 plus 6, so 310. Yep, we did it correctly, guys. 136 base 16 is the answer. Alright, we're approaching 20 minutes on the video, so I'll try to make the next one short, and then we can go ahead and do the quiz. See if we can finish this within half an hour. Don't worry, all the videos will not be half an hour long or an hour long in the future. It's just these take a while to make, the base conversion ones. So these will probably be the longest. The programming ones will probably take like 10 minutes. So don't worry about that, or even less than that, maybe 5 minutes some days. So these will probably be the longest tutorials. Algorithms videos they'll probably be long too. So just expect to waste half your lifetime on these videos. So number 4, let's do some division in different bases. So let's go ahead and take the first number and the second number, and we divide it, and then we convert it to base 10, and then we can go ahead and do division. So 1 0 0 0 0, make the chart. Go ahead, 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth. We evaluate this, we get 16, and then we get 8, then we get 4, then we get 2, then we get 1. So let's go ahead and zoom out a bit. So 16, 8, 4, 2, 1, yep. Alright, so we only have a 1 in the 16's place, so this is the same thing as 16 base 10. Oh gosh, it's back. 16 base 10 divided by what 100 base 2 is in base 10. So let's go ahead and reuse this chart and put in the number we want. Alright, so we can just follow these in with zeros. So 1 0 0 base 2. So we only have a 1 in the 4's place, so this is 4 base 10. Let's go ahead and zoom in and rewrite these. So 16 base 10 divided by 4 base 10. 16 base 10 divided by 4 base 10. And now we can go ahead and do division like we normally do. 16 divided by 4 is equal to 4 base 10. And since we already know the value of 4 base 10 when we were working it out, we can just go ahead and put it down right here. There's no need for conversion since this part is 4 base 10. So, yep, that is pretty much sums up the lesson in converting numbers that are in converting expressions that are in different bases, evaluating them, and getting them into your desired base of base 10 or any other base. So I hope you guys enjoyed that lesson. Let's go ahead and move on to the quiz now, which I've got pulled up right here. Let's not save that. So here's the quiz. Number 1 should take a little bit of time, not that much though. Number 2 is really short, so we want number 1 in base 8, and we also want it in base 10, and for number 2 we want it in base 2 and base 10. So I'm going to go ahead and pause the recording. You go ahead and pause the video, and you go ahead and work these out, and then we'll go over the answers once we come back. So good luck. Alright guys, let's go ahead and go over the solutions. So for number 1, the base 8 solution or the octal solution is 1 0 1 4, and the base 10 solution is 524. And then number 2, the base 2 solution is 1, 0, 1, 0, 0, and the base 10 solution is 20. So 10, 14, and 524, 1, 0, 100, and 20. So those are the solutions. Now let's go ahead and take a look at number 1 and work through it. So we need to convert the first number and the second number into base 10. So let's go ahead and make our chart once again. 756. 756. And then we got 8 to the 0, 8 to the first, and 8 squared. Go ahead and evaluate these place value terms. 1,864. 7 times 64 plus 5 times 8 plus 6 times 1, so you can see our number there, 756, and then all the place value terms, 64, 8, and 1, so yep. Alright, now we can go ahead and evaluate this expression. So 7 times 60, that would give us 420. 7 times 4, that would give us 21, 28, so 420 plus 28, 420 plus 28, that would give us 448 plus 40, that would give us 488 plus 6, so 494 base 10. So that's what that is in base 10. Let's go ahead and zoom in, fix that. 494 base 10. Alright, and then let's go ahead and reuse that chart for the second number, 36. So this one should be a little bit easier to compute in our heads, since it's only 2 digits. So we can go ahead and wipe out this third column there. No! Curse you, right click. Alright. Good old paints. Alright. Let's erase the third column for real this time. Yes. Alright. There we go. Alright, so and then you need to put, what is this, 36 up there. Alright, now we do 3 times 8 plus 6 times 1. 8, 16, 24 plus 6. That gives us 30. Base 10. Go ahead and zoom in and write that down. 30 base 10. And we can go ahead and add these numbers together. So that would give us 524, our solution in base 10. Now to get the solution that is in base 8, we're going to go ahead and use remainder division, since this is a pretty large number. So let's go ahead and list some powers of 8 we can use. We can go ahead and use some of this chart again. Alright, so 8 to the first, 8 squared, and I'd say 8 up to 8 cubed would be good to go. 8 squared and 8 cubed. So 8 squared, that is 8 times 8, which is 64. Now, to find 8 cubes, there's 2 different ways we can go about this. We can multiply 64 times 8, or you can just do, because 8 times 8 is 64, and then you multiply it by 8 again. So that would give us, 64 times 8, that would give us 480 plus 32, which would give us 512. And another way we can do this, if you have your powers of 2 memorized, here's a little shortcut. You can use the power to a power property of exponents when we break 8 down. So 8 is the same thing as 2 cubed. 2 times 2 times 2 is 8. So we can substitute 2 cubed in for 8 whenever we want 8 cubed. So a power to a power you multiply, so this gives us 2 to the 9th. And now you can just go ahead and keep doubling if you know a certain power to. So let's say we know 2 to the 5th is 32, multiplied by 2, 64. That gives us 6. So, and then we go to multiply by 2 again. That gives us 2 to the 7th, which is 128. Multiply by 2 again. That gives us 2 to the 8th, which is 256. And then you multiply by 2 again. That gives you 2 to the 9th, which is 512. 512. Alright, so that's just a bit of a shortcut. That looks like 5 divided by 2. So that's just a bit of a shortcut for you if you know your powers of 2, or if you prefer doubling instead of multiplying by 8. You can go a bit faster. So now we have our powers of 8 we need. So this is less than 512 is less than 524. If we multiply by 8 again, that would be greater than 524, so we're not going to do that anymore. So we have all the powers of 8 we need to go ahead and do remainder division. So let's go ahead and put down 524. Go ahead and divide it by 512. That gives us 1, remainder 12. Yep, 512 plus 12, 524. Alright, so now we have that 12 divided by 64. That gives us 0. Remainder 12. Go ahead and divide by 8 now. 12 divided by 8 gives us 1, remainder 4. Divide by 1. 4 divided by 1, that gives us 4, remainder 0. Go ahead and read all the place value terms we have. So we have 1, we have 0 for the 64s, we have 1 for the 8s, and we have 4 for the 1s. So we can go ahead and check that. 512 plus 8, 520, plus 4, 524. So that's the answer in base 8. Now let's go ahead and take a look at number 2, and then we can go ahead and finish this very long video. Go ahead and pause and rate. Alright, so number 2, this one doesn't take as long. Let's go ahead and make the final chart and we'll be done. 1, 1, 0, 1, 1. Bam, bam, bam. Alright, so let's go ahead and put down the powers of 2. Yep, alright, so 2 to the 0, 2 to the first, 2 squared, 2 cubed, and 2 to the 4th. Almost said 8 for some odd reason. Probably because 2 cubed is 8. So 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. Alright, so we go ahead and add all these, add all the terms that have 1 in them. So 16 plus 8, that gives us 24, plus 2, 26, add another 1, that gives us 27, base 10. 27 base 10. And then we go ahead and subtract that. Oh, we can probably reuse this. That'd be the smart thing to do. So now we can go ahead and erase these 2 columns, though, I guess. So let's go ahead and find the value of the second number in base 10. And then that's pretty much it. So, alright, so we have 1, 1, 1, so we add, go ahead and put 4, 2, 1 down. So we go ahead and add 4, 2, and 1 together. That gives us 6, 7, so that gives us 7 in base 10. 27 minus 7, that gives us 20 in base 10. So we got our base 10 answer of 20. Now we can go ahead and convert this into base 2. go ahead and use remainder division. I mean, not mountain division, since it's pretty small. Alright, so we got 21. I mean, what? Fine, why? 20, not 21. Okay, that was weird. We'll just ignore that. So we got 20 divided by 2. We got 10, remainder 0. Divided by 2. 5, remainder 0. So 10 times 2, 20, remainder 0. 5 times 2, 10. Okay, yep, we're doing good. 2, remainder 1. 4 plus 1, 5. Divided by 2 gives us 1. 1 times 2, 2. Remainder 0. Divided by 2 again. Gives us 0. Remainder 1. So now, since we went up the mountain, let me just make sure we did the division correctly. Yep. Alright, don't want to mess up right at the end. So now we can go, we went up the mountain, now we read down the mountain, so we go 1, 0, 1, 0, 0 for our answer. We can go ahead and check this. So that's 16 plus 4, so 16 plus 4, that is indeed 20, and we are finished with this very long video after over half an hour. So, and we're done with the topic of base conversion, so go ahead and give ourselves a clap. You know, it's probably like 2 to 3 hours of video, and oh, why paint doesn't want us to end. Spent like 10 hours of preparation for these 4 videos, so the next videos they'll go a lot faster, so we can actually get moving along, get learning some stuff about Java, and they'll be a bit more fun, a lot less math related. We'll just be exploring the Java language and some cool features, and we can start writing our own programs. So what I'm thinking about for the next 5 videos, we're going to be talking about the basics of programming in the next video, and then we're going to be talking about variables and data types, and I'm going to be talking about how to convert those data types into other data types. Then we're going to be talking about some advanced math in programming, and then we're going to be talking about Boolean simplification and expressions. And also in the next video, we're going to be talking about which topics we're going to be covering, and just give you a topic list and give you an idea of some of the upcoming tutorials. Probably going to have a list of all the tutorials, at least a list of the first, like, I don't know, 50, or maybe not, that's too much, at least the first 30, I'd say. I'll have those planned out, and then I'm probably gonna make a couple of appendices after I finish making all the videos I want, but we'll explain all that in the next video. I hope you guys enjoyed this very long video. Thank you for sticking with me. If you had, now you know how to convert. You're a base master now. You know how to do everything with bases now. So I hope you guys enjoyed. Rate, comment, subscribe, and I will see you in the next video where we start some Java programming. Bye.